This is the Discovery Files podcast from the U.S. National Science Foundation. The U.S. National Science Foundation is driving cutting-edge research in artificial intelligence concepts and techniques by investing over $500 million to establish national artificial intelligence research institutes. These institutes are the result of a national competition to support research and education hubs at U.S. colleges and universities. The AI Institutes will collaborate with industry and government to advance the frontiers of AI, as well as a range of science and engineering disciplines and societal sectors that stand to benefit from AI innovation. We are joined by Tess DeBlanc-Knowles, Staff Associate for Technology Policy and Strategy in the Directorate for Technology, Innovation, and Partnerships at the U.S. National Science Foundation. Ms. DeBlanc-Knowles, why is supporting AI research critical?
I think that the importance of NSF's investments in AI really can't be overstated. To understand why I say that, we can look back to the historical role that NSF has played. So many of the AI advancements that are making news today, and that's both the innovative products that are coming out, but also the talent that's developing them, are made possible by NSF's long history of investment in AI that dates back decades. And we have NSF's research investments to thank for the development of techniques of reinforcement learning, which are playing a role in chatbots, making them more responsive, helping manage supply chains, controlling self-adjusting thermostats, and much more. And reinforcement learning is part of this broader field of machine learning, which is behind generative AI like voice recognition systems, image recognition and generation, and even systems that we all use every day that distinguish real email from unwanted spam. NSF-supported research investments built the foundation for these methods, as well as others that are driving AI tools and applications of today. So, going forward, the support that NSF provides to our national AI ecosystem is, as I see it, only going to become more critical, because we're not only supporting that necessary foundational work that will continue to set the foundation for new directions in the field, but we also support really critical work to apply AI to other fields, such as agriculture, healthcare, education, and others. And we also support the development of trustworthy AI approaches, which are becoming increasingly important as AI products are being deployed to market. And there's really still a lot of work that needs to be done on their research side to develop the approaches that are needed to make the behavior of AI systems more robust and verifiable. And finally, NSF has a really pivotal role in supporting the development of AI talent. So from K-12 education to experiential learning opportunities to enabling more Americans to pursue advanced degrees in AI. And we do this at a truly national scale, making these opportunities available in all regions and in states.
How are the National Artificial Intelligence Research Institutes supporting national goals?
What I think makes the National AI Research Institutes really unique is in their diversity and in their reach. And the diversity that I'm talking about is in terms of their areas of focus. Some are tackling fundamental challenges in AI, such as more efficient training of neural networks or effective and trustworthy decision support systems, where others are applying AI to critical areas like climate adaptation, sustainable agriculture, supply chains, and effective learning and education. And, that differentiation is a little stark when you look at their specific research thrusts. They are all doing a little bit of both. For example, our education-focused institutes are making fundamental progress in large language models. But further, given their structure as these multi-organization consortiums, the network of National AI Research Institutes now reaches into almost every state. And so that investment has helped catalyze partnerships among more than 100 organizations who are participating across those 25 institutes. So, because of that, the institutes are really a direct reflection of our national priorities on AI that were recently articulated in the Biden administration's executive order on AI. Essentially, that we have to both manage the risks in AI and advance innovation, and that we need to expand opportunities for more Americans to become involved in our national AI ecosystem. And the AI institutes really work towards all of these objectives. They're advancing AI innovation. They're helping mature trustworthy AI approaches. And they all have this mandate to cultivate the next generation of talent. So not only within their universities, but also through engagement with K-12 schools, community colleges, and other partners within their regions.
The AI Institute for Intelligent Cyberinfrastructure with Computational Learning in the Environment, or ICICL, is working to build the next generation of cyber infrastructure, transforming today's AI landscape by integrating plug-and-play AI to leverage insightful analytics, modeling complex systems, and enabling automation broadly. DK Panda is a professor of engineering and computer science at The Ohio State University and director at ICICL. Dr. Panda, why is a robust cyber infrastructure important?
People are interested in using AI solutions, but at the same time, they have to be, like as you said, robust. Robust in the sense not only from performance, it has to be scalable, it also has to provide a lot of solutions towards privacy, accountability, ethics. Now, unless you have all these solutions being integrated together, a lot of communities or people are afraid to use those things. So from Icicle's point of view, that is also another goal, that we want to have a comprehensive solution to make sure that those solutions are applicable and become very robust over the years. Let me give a very concrete example. I think it will be very simpler. Think of like a farmer. Agriculture is a very big focus all over the world. In 2050, we'll cross 9.3 billion people. We have to feed them. So we have to develop this agriculture field in a much more smarter manner. So today, if a farmer wants to see that his or her field has a lot of diseases, they still go and spray pesticides. But are they doing it in a very intelligent manner? Are they doing it in an eco-friendly manner? And this is where we want to help. Think of like a modern AI. We can fly a drone. Drone can actually detect the field. It can, based on our AI models of the crops, it can actually come up with a solution saying, okay, that part of the field has disease 1, that part of the field has disease 2. Then you send these instructions to the tractors. The tractors can actually go and very precisely spray. So this is kind of our broad goals, to really help these kind of farmers, or think of like a store managers, or think of like a health commissioners. So our slogan also in the Icicle, you would have seen, called Democratize AI. That means we want to reduce the barrier for these people who are neither experts in AI, may not be experts in computer science, but we want to bring innovative solutions to them so that as a fingertip, they should be able to take the benefit.
What are the challenges developing AI cyber infrastructure?
These days, the AI components or solutions are running everywhere, like starting from our iPhone to a drone, to a data center. Even though these solutions are running, continuous innovations are taking place with respect to hardware, with respect to algorithms, with respect to middleware. And at the same time, a lot of data is also being generated. And then the question is, the end people want the solutions also even faster. Okay. And the final thing is that there are not enough skilled people to bring all these solutions together. So those are the kind of challenges actually our institute is trying to solve.
How is Icicle approaching these problems?
We have a multi-pronged approach. So first we are trying to do plug-and-play design, come up with different modules, come up with the different parts, so that as the hardware, software changes, the data set changes, people should be able to plug and play, just like Lego boxes. They should be able to put the solutions, and then you should be able to provide the solutions to the end users. While developing these, we are actually trying to also interact with 3 use-inspired science cases. Very common ones like a digital agriculture, animal ecology, smart food sets, so that not only we can prototype, but we can actually validate our designs. So once the solutions work, then these kind of solutions can be extended to other disciplines, other verticals. Through these solutions, we are trying to democratize AI. So that is also another important focus in our institute, because AI is so big, many communities are a little bit afraid to use those things. So we are trying to reduce the barrier so that we can actually provide the solutions and then they can actually use. And through that process, because there are not enough people are there, we have a lot of focus on training, education, workforce development, so that we want to make sure that these kind of solutions are sustainable.
The AI Institute for Agent-Based Cyber Threat Intelligence and Operation, or ACTION, seeks to change the way mission-critical systems are protected against sophisticated, ever-changing security threats by making fundamental innovations to integrated learning and reasoning, agent interactions, and strategic gaming and tactical planning systems. Giovanni Vigna is a professor of computer science at UC Santa Barbara and director at ACTION. Dr. Vigna, how can AI and intelligent security agents improve the way computer networks are protected against attacks?
It is important to have help, and help comes in many forms. Intelligent security agents can be ubiquitous, can be in many places in the network, can replicate and cover all the different angles that need to be covered, and also can filter information so they will bring to humans all the real nuggets, the real important pieces of information that are fundamental in decision-making. And so in order to do that, we have to develop new way to represent knowledge, to reason about facts that happen in our network. And so there are many aspects that are very foundational for AI that need to be addressed. I think that the most important thing is to be able to protect very large and very critical networks. And the main problem is that humans are not anymore able to address the scale of the problem or to react to the problems in a timely fashion. And therefore, the Action Institute brings new innovations in AI to bridge this gap. And in particular, we want to bring forward intelligent security agents, these autonomous reasoning elements that are able to help humans actually protect the networks.
What is the most exciting challenge Action is working on?
I think that an important challenge is the collaboration between AI and humans. In our institute, this is really the agent-human collaboration. How do they talk to each other? How do they explain to each other what are the important things? So on the one hand is the agent going to a human being and explaining something that could be a series of very obscure events, but they actually represent the compromise of a mail system. And at the same time, for the human, conveying to the agent the importance of that system. So there is a bridge between the way in which humans think about things in a natural language and in a very high-level semantic way, and the way in which agents think about things in terms of fact, rules, reasoning, learning from data. And so I'm really excited in building a bridge that allows these two worlds to actually integrate and collaborate for the greater good.
You mentioned different worlds there. You've worked a lot in the hacking world with Capture the Flag events, and I wanted to ask you, what is the greatest misconception about hacking, and how can it actually be helpful?
Many think that hacking is this malicious hacker trying to vandalize a network or to steal information or do all sorts of damage. Actually, hacking is a mental attitude, is going beyond what's obvious and trying to understand how things work. What are the assumptions that have been made in building something, and see if these assumptions can be violated to kind of subvert the intended functionality of a system and bringing a system to do something that was unexpected. And this helps because it's sort of like building a safe. You want people that know how to break a safe to design the next safe so they cannot be broken into. And this is the work that we do through Capture the Flag competition, exposing young people in a competitive and fun environment to important security concepts.
The AI Institute for Edge Computing Leveraging Next Generation Networks, or Athena, is working to transform the design, operation, and services of future mobile devices and networked systems by introducing AI functionality to next-generation edge computing networks. Yiran Chen is a professor of electrical and computer engineering at Duke University and principal investigator at Athena. Dr. Chen, what makes edge computing more challenging than cloud-based centralized alternatives?
It's a very good question. When we're designing edge devices, we want to make sure a device will be small and portable. The first challenge is the limited computing resources which we have. When we're designing the edge devices, we usually design device as very small. So small device will help the power consumption reduction, but also constrain how much computing resources we can integrate on the device. That's also make us another challenge, which means we need to design the model which can while running on those devices. This model must be small, light, and also efficient. The model can also handle the privacy issue because those edge devices with the model, you're going to handle the data close to the users, which means private or personal. The third challenge will be the connectivity, because we're now talking about connecting a lot of edge devices, if not millions or billions. Those will give us a challenge regarding the communication bandwidth and so reliability. Some devices may have the limited computer resources. Some devices may have more resources. Some devices may be connected. Some devices may have a limited bandwidth. And also, we want to make sure, there are going to be some malicious devices. We need to identify them and make sure we can prevent them from attacking our system. So in short, we have to design a system which can be scalable, efficient, robust, and secure.
How can we improve AI efficiency?
If you carefully look at the AI models, people have the impression, or maybe wrong impression, the AI model can be very, very large. Which is true, because if we increase the size of the AI model, the model can be more powerful. However, The model has a lot of redundancy. It's very similar as a human brain, which makes sure we have such robustness. What we can do is trying to reduce such a redundancy and make sure we only need, the minimal side of the parameters or the connectivities in the model to provide all the services which we need.
How does NSF support make this edge computing research possible?
NSF is one of my major, if not the most important research grant sources to support my research. It's not just about money. It's about the opportunity for us to freely pick up the topic we want to work on without worry about many other constraints we have, usually from some other funding agencies or the resources. It's going to be the one, if not the single resource, which give us such large freedom and also taking the huge risk for those opportunities.
The AI Institute for Future Edge Networks and Distributed Intelligence, or AI Edge, is working to create an environment that will help develop the United States technological leadership in next-generation edge networking. Ness Shroff is a professor of electrical and computer engineering and computer science engineering at The Ohio State University and director of AI Edge. Dr. Shroff, what are the primary goals of AI Edge?
So there are two main goals. One of them is to develop new foundational AI techniques in order to design future networks that can provide very, very high-speed communications, ultra-low delays, ensure that the communication is personalized, is secure, and private. So that's one aspect of it. And then this intelligent networks that we design will also be used to facilitate distributed intelligence because the future of AI is going to be distributed AI. And so the idea will be that these networks will essentially allow collaborations to take place between different edge devices in order to solve grand challenges that might happen in distributed AI.
What are the challenges to implementing AI in communication networks?
There are challenges that happen in multiple scales. The first one is designing AI that fits the needs of communication networks. So that's challenge number one. So if you took an off-the-shelf AI component and applied to communication networks, that probably would not work well at all. The second one is being able to take the AI algorithms and implement them in software that can be done in a lightweight manner, so such that different types of devices, regardless of their computational capabilities and communication capabilities, can use them. So that would be another big challenge.
How can AI and communication networks benefit each other?
There are many, many different ways in which communication networks can benefit AI and vice versa. I'll kind of give you three very quick examples of how AI can benefit, let's say, communication networks. The first one is in network control. So AI will do what AI does best, which is analyze a whole bunch of data and be able to make predictions. So you can make predictions based on historical data as well as incoming data in designing communication networks such that you can have them be very, very high speed, have very, very low delays. And that in turn enables very cool applications in the future like holography, which essentially takes away the shackles of geography. So it would be essentially like we are in the same room even though we are thousands of miles away. Think of Star Trek. That could be an example. Another big example is AI can be used to detect anomalies in networks, so prevent security threats from happening, can verify that the protocols that we are developing don't have vulnerabilities in it. And also the third example would be it can self-heal. So, think of a Taylor Swift concert or a football event that causes a spike in a lot of the traffic. And what happens in that case is that thousands of network parameters need to be reformulated, reorganized, and the AI can assist the humans in doing that quickly so that these networks can be operational. Definitely important for, let's say, a hurricane passing through or a tornado happening. Let me give you three quick ones for how networks can benefit AI. The first one would be, let's say you have autonomous transportation. So you can have a very high-speed network that allows edge devices as well as AI running on the cars to sense the traffic and road conditions and communicate with each other to ensure that autonomous driving is safe and is efficient. And this has applications beyond just self-driving cars. You can think of smart, intelligent manufacturing where this could be applied as well. Another is democratizing AI. So you can have, a very large AI problem that you may want to solve, but you don't have resources to buy the computer capabilities, let's say from an Amazon or a Google to solve it. So what you could do is you could use lots of different lower powered devices to coordinate and solve this big problem by parallelizing this big problem and move it across network devices. And the third one, I would say, would be in collaboration in order to solve future grand challenges in AI. So basically what you would do is you would combine the power of different AIs from different places in the world through this high-speed network in order to solve problems like the protein folding problem, etc. Very, very large problems. Anyway, these are just a few examples. I think the space of possibilities here is quite large.
Special thanks to Tess DeBlanc-Knowles, DK Panda, Giovanni Vigna, Yiran Chen, and Ness Shroff. For the Discovery Files, I'm Nate Potker. Please subscribe wherever you get podcasts, and if you like our program, share with a friend and consider leaving a review. Discover how the U.S. National Science Foundation is advancing research at nsf.gov.